Hey everybody, this is Larry. This is me trying to do the virtual contest for earlier today for me. Ooh, luck plus minus 10. The weekly contest 370. I actually was going to do an intro, but if you want to see my kind of traveling intros, you gotta, hit this. Ooh, what am I doing? You have to hit the subscribe button, press the join button, or whatever other buttons, and let me know what you think. I am here in Kagoshima right now. And yeah, let's get started. I mean, I don't have much to say, but hope everyone had a good contest. I haven't looked at it yet, obviously, because if I did, then this would be really silly. But yeah, let's. Am I ready? 5, 4, 3, 2, 1, go, go, go! Let's see. Already a little bit slow. Oh no, another double question. They really getting lazy nowadays, but okay. Mm-hmm. All right. Well. Yeah. Okay. So. That's weird, though. Maybe not. I don't know. Let's do it this way. Wait, what? No, what am I doing? Yeah, kind of slow for easy, but I just want to make sure. I'm not sure that. Oh, it's transitive. They kind of hid it in the notes again, or constraints. That is transitive. So okay, 0 and 1. Let's give it a spin. Hopefully, I didn't misread the question. Nice. Oh, this is a different problem. I am. Wow. I was like, how are they going to make it so that you have to be faster? But okay. Okay. So there's a unique chapter. Okay, fine. And it's still only 100. So this is, I guess, it's only Q2. Let's just construct a graph like last time then. Right. Right, and then and then basically, I forget which way it goes in Ford's. Is that true? Yeah. Something like this, maybe. Right. So, if I beats J, or if I beats K and K beats J, then I beats J. Okay, fine. There's always a. Does not have any cycle. Actually, I didn't see that, but wait. Oh, it's not because it's not full. It that might not. Maybe I overcomplicated this, to be honest. Okay, so because I misread this. Okay, fine. But I didn't realize that it was a DAG actually. Or I mean, it is. I don't know. Or I didn't really realize that it doesn't have any cycle. So okay, fine. What I actually want to do, I overcomplicated this. Who's this? Right, and then now if this then loses v increment by 1, and then that means that right, for I in range of n, if its losses of I is greater than 0, then enter the append I. If I think I'm just I actually expected this to be harder for whatever reason, so I think I just kind of didn't read the problem very well. Let's see if I made a mistake anyway. Okay, yeah, I just kind of overcomplicated it. All right, maximum score after applying operation is on a tree. Okay, you have a tree neutered at 0, 2D integer array, the edges, okay, of the tree. Pick any node I, alright, add value sub I, and then set to 0. Tree is healthy if the sum of the values from with any, okay. Okay, that means basically, what is it basically? Basically, you're trying to keep it healthy, and the way that it is healthy is if a node for everything is 0. Okay. Okay, so can we do, is it DP? Basically, what are we, so basically it's either that this particular node we have to think of the opposite is what I'm trying to do. Basically, if you keep this node, then you get to sum up. Okay, let's say we keep this node, then obviously the subtree, fine, we get to keep all the score. How do we propagate that up? What is the brute force memo thing? Okay, that means that basically we either keep, if we keep, so we go up, down, right? So that means that we already got, then we sum up everything on the subtree. Okay. Otherwise, if we don't do it, then we have to individually calculate the paths. Right? This is kind of tricky to think correctly, to be honest. But I think on node and n is fine, but I mean something like that, but I'm trying to think precisely. So okay, let's say we take 0. Let's say we do 0, then that means that, okay. So, okay. This is a medium, wow. And the heart is just a regular heart, okay. Something like this, right, maybe? Not done node. Whoops. So if not, so if node is none, then we just return 0 probably, right? Well, if required, yeah, maybe that's a weird case anyway. Okay, so let's say there are two cases where we take and don't take, but I'm trying to think for what that means, right? So if we already taken it, right? So if required, or maybe needed is a better word, I don't know. That means that we still need to finger thing. So if not needed, then we just kind of am I going to do that? I mean, I'm trying to be sure that no, each node can only do it twice. I'm trying to think about the start diagram one, which we run into a lot of issues in the past, but no, this can only go twice for each node, so it should be good. Okay, so if not needed, if this is not needed, we just kind of, oops. Okay, fine. For u, we and edges, ye of u, we're setting the adjacency list. Right, and then now if this is not needed, then we just go through it, right? So total is equal to 0. For total is equal to no dot value, and then for u in e sub. Oh wait, why did I think it's a node? Whoops. So yeah, total is equal to y sub node, right? And then for u, then we add calc of u needed and not needed, so that means this is false, right? And also if u is not equal to parent, right? I guess I just left out parent. I'm so like, but there's only one parent because there's a rooted tree, so it should be okay, right? And then we return total. I know I'm doing a double negative here, kind of, but I think this is the more base case. And then now if it is needed, then we either take this. So if not needed, you always just take everything because does that make sense? So otherwise, you can take this, take, right? So we take, then take is equal to 0. Y use up node, and then take. I think it's just this too. So then now, yeah, right. So that's take, and then leave. What does leave mean? Leave means that we. Wait, what does take mean again? Maybe I can mix them up. So take means we take all the values. Okay, fine. If we need to leave one behind, then and we leave. Oh no, I confused the take. So I think this is leave. So leave is equal to 0. And then now we take all the ones behind. Okay, fine. But if we do take this one, then what happens? Then all the other ones in the node will still have required. Right? Yeah. Basically, if it is true, then you have to take, because, or if you take it, this is mostly right, but I'm missing an if statement somewhere. This is pretty hard for medium maybe, but I don't know. Okay, so this is needed. So then we already took it, but here we're taking it, so the children needs to be taken. We have to do a leaf node thing, right? So yeah, yeah, so children is equal to 0, and then if children is equal to 0, that means this is a leaf node. Then tick is equal to negative infinity, because we're forced to leave it behind, basically. Okay, maybe that's good enough of a hack. Let's see. What am I missing? Of the parent. How am I so sloppy? I think I changed that definition as well, but still, thought I could have done it. 1140. Let's give it a submit. Hopefully we don't mess up too much. Okay, good. That was kind of hard for Q3. How am I doing in time? 46, not bad, not fast, but okay. I mean, I had the idea, but it's just kind of so many things to think through. Anyway, Q4, let's go. Maximum balance subsequence sum. Subsequence is balance if it holds. Num sub j minus num sub j minus 1 is greater than so the numbers are greater than indexes, right? What is n? N is big, so we have to think about it. Oh, it's the sum of the elements. And people already gotten it? People are so good. Oh, excuse me. Oh man, should take a nap. Okay, so the first thing to know is we have to do the trick, right? What's the trick? If you have something like this, this is ugly, but maybe understandable. I'm slowing down a little bit, but yeah, and you want to change the things so that minus this on both sides, and then add subtract this from both sides, right? Something like that. And then yeah. Anyway, but so then yeah. So what does that look like after we converted this, right? For full explanation, watch the explanation video. I'm still just working out in my head, right? So that means for ix in nums, print x minus I. I just want to visualize this. That's what I'm doing now, and it's going to give me an error because now they actually do a thing. But before we turn value, oops, enumerate. So 3, 2, 3, 3, right? And then the next one is 5, 1. What is the 13? Because it's 5 and 8. So then it's 5 and 5. And I think this is, as long as it's increasing, is it that it is increasing? Because the 2 is increasing, but 2 and 5 is no. Oh no, this is 5 is good too, right? So then now it just becomes longest or not longest, but the total increasing sum of this thing. Okay. That's tricky though, isn't it? I mean, basically, now you could do an LIC for the longest increasing, but I have to think about how to do it for the longest something, right? And also, clearly, this does not. Oh, I mean, this works. They are balanced. It's just that because of negative numbers, you only want one of them. So it's not. So it's not just the longest. We do have to figure out how to get this to sum in a good way, because this 5 and this 5 is good. Actually, the -2, -5, and 5 is good too. So it is. So we have reduced it to LIC, longest increasing subsequence. But how do I do the sum of? So it's not the longest increasing. It is sum of increasing. So -2, you're trying to find the last -2. Is that is it just as straightforward as you think, or am I just confused? Let's play around with it then, right? So okay, so you have the LIC array is right, and then now you want to binary search on x sub I, right? So left, yes, and then we want it to be a tuple. It's not quite true though, right? It's not quite true that you want the longest increasing because of the negative numbers. Can I do anything about the negative numbers? People have gotten it though, so it's not like, I mean, it's not easy, but people seem to be getting it. A -1 is not enough of a sentinel value, but so what am I biasing? So there's that, and then basically you're just trying to say it is not the longest though. I think that's the part that I'm struggling with. So you're trying to, okay, so what are you doing? You're binary searching on things that ends in -2, and then you max that. So if you add a -1, it just won't do anything. But because the greedy doesn't help here, right? Or at least the greedy with respect to the length. How would I do it? And even this, right? So let's say this was a 4. Actually, that would just be whatever, but let's say this was a 2. Or even let's say this was a 2. Then how do you pick the 3 instead of the 2? Right, because if we have this, we want to, oh, whoops. Yeah, whatever. Did I not print? Oh, I did not print. Yeah, so then this is 2, 2, 3, 3, but you actually want the 3, 5, and 6 to get the 14 instead of 2, 5, and 6, right? Okay, so what am I doing? So, okay, so we set 2. Okay, so let's say we do all these, and then we normalize it to 10 to the 5th. And then what does that mean? That means that we're trying to figure out are we trying to figure out the max of all the numbers of 3 or less, and then update 3. So the max of the prefix, and the prefix we can do with binary index tree. Am I kidding me? Is this the way to do it? I think it is. Or I don't know if this is the only way to do it, but it is our way to do it. You can't see me doing some cheating right now. No, and by cheating, I mean I'm just looking at my binary index tree things. Okay, so I have right, and then we have to renormalize this, right? So, what are we doing? We want to renormalize x sub I, right? So, okay, yeah. Sorted is good, right? Or set maybe. Plus I, right? And then for x in list of, I think this is sorted already, but I just want to I like writing it this way, right? So then we want to enumerate this to lookup of x as equal to I, right? So then now this x is different than this x. Is very confusing, I know, I'm sorry. And then now we have 3 is equal to let's just say n plus 5 because I can't count. I always forget how to do these. And this is a total binary index tree. I want a max binary index tree, right? I could do that, right? That's not a thing. Let me Google this. Getting Japanese results because I'm in Japan, which is interesting anyway. Okay. I'm not gonna lie, I thought I knew this, but I just wasn't sure. I'm not sure that it generalizes for max. If not, then we have to use a segment tree or something. Yeah, it's been a while. I mean, it's either that or another segment tree. We could use segment tree. But, okay. I have to actually learn segment tree one. But yeah, so this is get max, right, of I. So, I think this is, and this is actually negative infinity, right? I think that's fine. And then otherwise, how do I do updates there? I mean, that part I kind of knew, but well, we only update if it gets higher. So right, so yeah. Nope. I think this is right? I don't know. I have to kind of is that true? I don't even know my API anymore, but we have plenty of time, I think. Well, that's not good. Because this should be, oh. Increasing is not quite right. Or like, we have to increase. Oh, okay. Maybe it's fine. Maybe I just need to get the variant and replace it. It's a replace, not an increase. Okay, fine. Update. Okay. All right. And then now what are we doing? Okay. Right. So then now for each number. Best is equal to, I guess, negative infinity. So now we look up, and actually this 0 as well, right? This is actually negative infinity as well. We want to get the, okay, so index is equal to x minus I, look up of this, right? Let's make sure that it doesn't give me like any outbounds everywhere. Okay, so then now we want the tree get max of index, right? So the current, so this is the current sum is equal to this, right? So if x is greater than 0, yeah, if x is greater than 0, then current sum we add it to x, and then we do an update. I guess if it doesn't, then we don't update. Actually, is that true? No. I mean, it is kind of true, but actually we want to do this first. Because this could be negative infinity plus... Actually... Yeah. Okay, so it's either this tree dot update of index, set it to current, and best is equal to max current best, or else if this is negative, we don't want to add it, but if this number is less than it, then that's good, right? So current is equal to max of x and current, tree dot update index current, and I guess this part actually overlaps, and then we return best. Is there like a -1 thing to do? Not possible. Yeah, because I'm returning something like this, but I shouldn't though, right? Because I should always return at least one number. I am returning some ridiculous number. Oh, so I see. Max of x current and current plus x. Actually, maybe I guess I could do this all the time. Oh, oops. 14, 13, -1. And I mean, it matches. And that's YOLO. Is there like 0 elements or something weird? Alright, good. That's a hard problem though. 40 dirt. I mean, not bad. I guess. If I could do a little bit better, but I mean, it's fine. Any shout outs? So I gotta, you know, gotta screen cap these babies. I don't know how I think about Q4 yet, to be honest. But Remix's 50th. Congrats! Actually beat me in time, but 2 wrong answers. And I don't know what this is, but I'm like half sneezing. I probably could have done Q4 faster, but it's kind of a hard one. I don't know. Maybe I can. I mean, I'm 43rd, so I don't think I'm reasonably should complain too much. Save VMK 26. Map props. Anyone? Drunk template. Well, for now. It has to finish, you know, strong. And Remix, I guess, actually technically going down. Same for Chi-Chi. Still not done yet. So I guess I beat them. No, I mean, this isn't a real contest, so it's hard to, you know. Also, they may just like finish now, and I guess now, I mean, I guess even they finish now, they'll be behind me. But it's a virtual contest, so you know, it's a fake contest. But I mean, I feel good. My feelings are good and real. But yeah. Yeah, I mean, I think that's all the shout outs I have or that I see. Let me know if I miss you. I'm usually very happy to give shout outs. But I don't know everyone's handle and stuff like this. Yeah. People are dropping a little bit. Anyway, I think that's all I have. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.